Hi, my name is Scott Redig. I work at Google on the OpenMatch team, and it is October 2020. We have some new people who are going to be contributing to the OpenMatch repo. So I thought I'd give a quick state of the union, what the code base is, where things are, that kind of stuff. By the way, you can tell it's October because I have my pumpkin and my spooky black cat. She's a black cat all year round. She's just spooky for October, get in the spirit of things. Okay, so let me present here. The first and probably most important thing to know about contributing to OpenMatch is to go to OpenMatch website, open-match.dev, go to the community tab, and down here, there's Learn and Connect. Both of these links are very important. First, there's the mailing list. The mailing list gets emails for releases. People can post questions there. But most importantly, when you submit a pull request to the OpenMatch GitHub repo, which we'll get to in a moment, the continuous integration that runs against, or the integration tests that run against your pull request are run in Google Cloud Build. And to access the results to see if what failures are happening, you need to be in the mailing list, and then you'll be able to log in to the Google Cloud Console and see the errors. It just gives you a view access to the build project. Another very important one is Slack. If you have questions, fastest way to reach people is probably through Slack. And we can have discussions about PRs and that kind of stuff there. Good for, working through issues and that kind of stuff. So obviously, from there, we can go to the GitHub page. I'm going to kind of do a quick overview of the top level folders here, and then we'll dive into some stuff after that. First, there's the API. This is the protobuf definitions. So if we're giving new extensions to the API, such as new methods to call, that kind of stuff, they go in here. CMD is a folder for the images produced by the OpenMatch project. The various images some of them are core components, some of them are testing and demo and that kind of stuff. To add a new image, you just add a new folder to this directory. You can see plenty of examples here of how to do it. And that will automatically add the make targets and that kind of stuff. Docs. So this is not the full documentation for the website. The website is in a separate repo, which, by the way, if there are major features, I think we expect them to be documented so that if you're adding the feature, add the documentation. That way, there is at least some level of documentation for other users to discover and know how to use a feature you've added, and it doesn't build up a backlog. But within here, there's some templates for the release. Probably can ignore that. And then here, there's a development guide. So I'm not going to go into the individual commands. I'm just going to, I think, leave it to this development guide here. It gives you commands to build the code, to install the prerequisites. And probably the most important ones here are like, how do you actually build the images? And it's really simple here. And this is the JProc is important for building it quickly. Oh yeah, it sits right here. Okay, it gives you information about that. Helps speed it up. And then how you can deploy to Kubernetes and iterate and that kind of stuff. So this is probably where I should be putting all of what I'm saying here, but good place for actual nitty-gritty writing code. Let's see. In examples, we have a few different things. If you want to produce an example for a new feature, awesome. Put it in here. 1 second. There we go. Okay. Then there's also the scale tests are in the examples for some reason. Past that, we have install, which is where any YAML or Helm work goes. You can see the Helm charts here. If you need to modify them, obviously you work in this directory. For the demos, we only have the YAML to simplify things a little bit, but for the most part, I think keep to Helm. It's not the greatest, but it's important. I'll get back to internal in a moment. PKG, this is the external facing Go packages for OpenMatch. So this is the match function is for anyone who is developing a match function in Go. They can go in there. There's some example or sample query functions or you can just use them to help making writing your match function easier. Obviously, not all match functions need to be written in Go because it's all based on protobuf. But this is where we put the stuff for that. PB is the compiled or like the transpiled from proto to Go. So if you want to call OpenMatch from Go, you can use it here. If you're trying to call from a different language, we don't support that in the repo anymore. It got messy trying to include a bunch of different languages. So just set up your own chain to pull from the API folder and build them as needed. Third party is some imported stuff. I think you can pretty much just ignore it. I don't remember what's in there at the moment. Tools, also probably not super important. And then tutorials, if you want to make any tutorial, that'd be awesome. I don't think it's expected. Here we, these line up with what's on the website in the tutorial section. Okay. So anything else here? The make file is pretty important. It's pretty long and could use some cleanup, honestly. And then, we have some Docker files and stuff just in the main directory. From internal, there is probably the most important folder in all of internal is app. App corresponds to the different images in command. As you can see here, these are the actual implementations of the different pieces of OpenMatch. So if we look at the front end, there is the front end Go, which is this is how I start up. Like if I want to start up the service, the calling command is just basically call to this, wrapped a little bit. This is how do I register the proto server that I want to run, any other functionality to run. And you can see here within the front end service, these are the actual calls to say create ticket or do the various things there. There is a pattern here, which is there's a front end service, and then there is another method that has the same name that's not in the service and is more functional. This is entirely optional. It's a pattern that was used a little bit. It's not used consistently. Don't feel like you have to use it. But if it makes your code cleaner, then you can definitely consider doing it. It's just code, code style, code cleanness. You don't have to follow it perfectly, depending on what the code is kind of telling you it wants to be, if that makes sense. So the different ones are in here. And then From there, let's see here. So API, there are internal APIs to OpenMatch, specifically the backend calls the synchronizer. So that's the only one there. And just like that, there is an internal protobuf, which is the Go compiled version of the internal API. Beyond that, there are a few of these are app main config, logging, RPC, telemetry are all the less OpenMatch specific folders for just generally starting up the service. It's used for logging, for the metrics we can see in Grafana, and just like making sure the server starts up correctly and that kind of stuff. It does a lot of the busy work. Probably don't have to work with it if you're just adding new features. Beyond that, the filter and the state store are kind of more tied to the app folder. So like if there's some common functionality or common place where you want to group things, generally speaking, the server-specific stuff goes into the app. The rest of it kind of goes into folders in this internal directory here. The filter directory manages the logic of, does this pool match these tickets? And it's imported by the query, but it's also just kind of standalone because we kind of wanted to define the logic, separately from the implementation, although we ended up using implementation. So there's a clear place where that is. State store is where we include all of the logic for interacting with Redis. The hope is that if someone wanted to replace Redis, this does, or have an interchangeability of you can use Redis or you can use something else. This provides an interface for that. The interface is very flexible, though, as in if you needed to do something else, just make it do something else. There is some way in which the logic is spread over both the apps. So like when I create a ticket, some of the logic is in the app. So like it verifies that the ticket is well formed in the app folder, and then it passes it to the Redis implementation here, which actually calls Redis and says, I want to serialize these bytes and put it in Redis this way. So if you are adding new functionality, kind of expects to make a change in app to add like a new call site, and then also a change in Redis to do the actual communications with Redis. Currently, it is only Redis, so the line is vague. I think if we ended up with a second database, it'd be more clear of where things need to live, whether it's actually usable or not. Given the state we're in, we're just kind of doing best effort. Don't rack your brain too much about it. Part of that, though, is I'll get to testing in a moment. Actually, I think that might be it. What do we have in it util? Just testing stuff. Okay. So the last part here is testing. Okay, this is some testing stuff for the end-to-end test, I believe. So this is probably how you want to most think about testing your changes. You can write tests in front-end. You can write tests in state store. But this is where you really want to think about, does my logic work end-to-end? The way, let's just look at some tests here. So fetch match tests. let's do ticket tests. So if we look at ticket tests, find a short one. Right. So this is a very simple test of I want to, this is kind of a test helper, OM equals new OM. I just get the test, and then I can call on the backend, OM that backend says I want to call I want the backend service. So this is the proto service. I can call release tickets, and this is my, proto request. And then I'm validating that I didn't get an error and it just gave me an empty response. So this is a very boring test, but it's like you can call release tickets with an empty request and just nothing happens, basically. We have a lot more complicated tests here, such as the actual release tickets test, which really runs through the paces of create a ticket. I try to look at these examples, try to follow the format of them. We try to make them understandable, but this creates a ticket, make sure the ticket's there, calls fetch matches, and runs the test, or runs a cycle. Make sure the ticket isn't returned by query anymore because it's in a pending match. Then release the ticket back to the pool, and then query again and make sure it's available. So this is kind of a way to do a full, this is what I expect the external behavior of OpenMatch to be. A notable part of this that wasn't in the previous example is that when it's running this in this test environment, the match function is not a predefined match function, but can be set by some functions on the OM struct. Here, you can say, well, I'm gonna return a match with the ticket that I am testing with here, and then in the evaluator, I'm just gonna say I expect to get something, and then I'm just gonna pass it on. And if anything else happens, then that's wrong. So the really nice thing about these tests is that they run both locally and in the cluster. So what I mean by that is if you just do a go test on the directory or on this directory or just the whole OpenMatch directory, you will run these tests locally. They will bring up a fake Redis instance in memory, all of the binaries, this base, actually we can see here. Right. So we say, let's bring up a bunch of services, set up the configuration, just run everything locally. This allows you to iterate quickly, make sure all the logic works as you expect. But once that's done, when you send a PR, this will actually also run in a Kubernetes cluster. So in that case, we don't start up any of the binaries locally. Instead, they are all we build each image individually, do a Helm install into the cluster, and do things that way so that we're testing all the logic locally, but we're making sure that things don't fall over in the cluster. Usually where you could break this is if you're changing Helm or that kind of stuff, but it should also detect any failed assumptions of, oh, I thought I was using a global variable between the backend and the synchronizer, and obviously that doesn't actually work. And don't do that. It obviously doesn't work. Running it in the cluster would detect failures that way. For evaluator and the match function, those are actually run in the test instance. So a fetch match will call out to the backend, and the backend for fetch match will call back into the test instance for I want to run the match function. So the MMF and evaluator are still run locally, but for in-cluster testing, everything else is run in the rest of the cluster in separate pods. you can't get to them other than to call them with RPC. So that is how I recommend people mainly focus on testing. Well, you want to break it down into a couple of pieces, right? I can give actually a good example here, which is the filtering. So the filter tests, we have a bunch of test cases here, which are reused elsewhere. But the filter tests say, I have a unit of logic that's a pure function for does this ticket, or like given this pool specification and these tickets, which ones match, right? That is very easily unit testable because you can just pass it objects and it will work. There are harder things to test, such as create a ticket, right? It doesn't do the specification of what it does is kind of just like what the code is. So it's mixed value or low value if you do unit test of it, because mostly what you're unit testing is that you're calling the methods that you expect to call. With that, you're just doing a change detector test. With that, you don't know if it actually works and it actually will create a ticket. But if someone goes and changes how tickets are created, now they need to fix this test, even if that test still works, or even if the new method works. I can say I expect to call Redis with this function, but I don't know if Redis actually behaves correctly when I call that function, and if the state is what I expect it to be. And a key characteristic of this code is that it doesn't have branches except maybe error handling, right? So it's do a bunch of things with a little bit of error handling, but I'm not really just making choices. So if you can split your code cleanly in those places, like this is a pure function that's making choices, I'm going to unit test it. This is just a bunch of commands I need to run to get the thing to work. I'm going to use the end-to-end testing, integration testing to test that. That is the ideal world. If sometimes things break down a little bit, either you need to do some wonky tests that are more unit testy on code that doesn't really like being unit tested, or if you can, just do a bunch of end-to-end integration tests to go over the if statements or logic that you have to use in your for your code in the end-to-end tests. So I hope this has all been useful. I look forward to seeing many awesome PRs with new features that everybody will love. I don't think there's anything else to cover. That was the main bit. Yeah. So thanks, everyone. Have a wonderful, spooky October. And I will see you all in Slack and various contributor meetings. Thanks. Bye.